after talking.
All right, so welcome. My name is Joonas, and I'm here today to talk about IMGUI-RS, which is one of my Rust projects. Today I'm going to focus especially on some of my experiences building this kind of library. So it's not going to be like a tutorial really to how to use this library and looking at all the features, but I'm just going to share some insight and experiences. So the first question is, of course, what is IMGUI-RS? Some of you have heard it, some of you have used it, but for most people it's probably a new thing. And this is IMGUI-RS. So it's a library for building user interfaces. This is one of the examples in the library. It's called test window. It basically just showcases all these kind of different kind of widgets that you can use. So yeah, IMGUI-RS is actually a binding library, so my code doesn't do that much. The heavy lifting is done by a different library. Oh, sorry. So there's a library called Dear IMGUI that is actually the library behind the scenes. So there's the question, what is Dear IMGUI then? And that library is quite popular immediate mode graphical user interface library, used in some commercial games as well, made in C++. It's mainly intended for this kind of content creation, debugging tools, user interfaces that are very tightly integrated into the game, or could be an application as well. Maybe not so much for the kind of interface that a normal user would see, but it's not impossible to use it for that. It's aimed for applications that have a 3D pipeline. Doesn't necessarily mean that there should be some 3D doesn't mean 3D graphics necessarily, just that the application or game is using some kind of modern graphics API, such as OpenGL. On the other hand, Dear IMGUI is not tied to a single graphics API. So, and the reason is that it outputs draw lists, which are basically data structures that describe what to draw, but it's not tied to a single graphics API. So in practice, you need some renderer code that takes the draw lists and then draws them. And only the renderer parts are tied to some graphics APIs. And one of the benefits is also that because the draw lists are just normal data, you can even serialize them and send them to a different machine. So you could have some kind of application running on one machine and running the IMGUI code, but you could have the renderer on a completely separate machine. Or even you could use WebGL to actually show the user interface. There's a lot of possibilities. Personally, I think this is one of the genius ideas, design choices in the original Dear IMGUI library, because it's very flexible. All right, and here's a screenshot I stole from the README from the original IMGUI library. So this is from a game called Wonder Boy: The Dragon's Trap, which was released quite recently, and the developer of Dear IMGUI worked on this project. So they've had a lot of these kind of tightly integrated debugging tools in the game. So you can see that there's a lot of things. And these kind of things are also possible with IMGUI-RS, although my library, my bindings library is still a bit rough on the edges. All right, let's take a look at the very simple hello world kind of thing with IMGUI-RS. So here we have a window that has a title, hello world, and there's some text, hello world, also inside the window. So this is the corresponding code in IMGUI-RS. So first of all, you have a UI reference that you use to create all these widgets. Then we call the window function. We pass the title, hello world. We also use this macro here. I'm going to explain that in a moment in more detail. Then we set the size, and we have a condition for the size, first use ever, which means that the first time this window appears, that will be the size, but after that it's resizable and remembers its own size. Then we build the actual window, we pass a closure that will build the contents, and in this case we just put some text there. And yeah, once again, use the macro. So yeah. So it looks quite simple, but the reality is that you also need quite a lot of support code to use this library. So just a quick look at what you need to do if you wanted to add this to your project. So there's some things that you need to do on startup when your game starts. One of the things is probably you need to do some kind of window context creation. This is not really something that IMGUI does or directly needs, but in practice, if you want to build something, you need to do this. So I just have some example code here, which uses a gluten library and Bloom. So first we create an event loop, then we create this gluten context, enable vertical synchronization, and then we create the window with the title and dimensions. And finally, we create a display, which is something that we can then draw to. So not IMGUI code, but necessary if you want to actually show something. Then we have the actual initialization of the library, which is very simple. You just call init. And actually, you also need to configure some keys. I don't have the code here, but basically the idea is that IMGUI has certain keyboard shortcuts and things like that, so it needs to know what does it needs to know what does it mean to press Control key, for example. Yeah. Then, in practice, you also want to initialize some kind of renderer. IMGUI-RS comes with some renderers. I'll explain them a bit later. But at initialization time, basically a renderer probably needs to set up some device objects. In OpenGL, for example, this means buffers and shaders and that kind of stuff. And also do some stuff with the font texture. So when IMGUI wants to render some text, it basically uses this font texture for the text. With the built-in renderers, this is very simple. It's just one function call. All these details are handled behind the scenes. So if we put all that together, yeah, it's not that much code. But yeah, there's some steps that need to be done before you can use this library. So then your game probably has some kind of main loop where you run some game code on each tick. And you also need to run some UI stuff. So let's take a look at the things that are executed once per frame. Well, you need to poll for input events. If you are building a game, you are probably already doing this, but yeah, this is necessary. So with the gluten library, you just call this poll events function, and then you can handle each event separately, do some stuff with those. And IMGUI-RS needs to know about some input events. For example, keyboard events, mouse events. So for example, in here, we are handling this mouse move event. In practice, this would be a much bigger match expression because you will have all the event types. But in this case, we just extract the current mouse position from the mouse moved event, and then we set some IMGUI state. I'm using a helper function here that's not shown, but yeah, it's very simple. So on each frame, you need to let IMGUI know about what's happening with the mouse, what's happening with the keyboard. Those are pretty much needed for the user interface. Then another thing that you need to do is start a new frame in like IMGUI terminology. So you call this frame function, and you give the size of the area where we are going to draw in points and pixels. In most cases, these are the same, but if you use a high DPI display, they might be different. It's important to pass both. There's also this delta seconds parameter, which is the time that has passed since the last frame. And this is used for things like counting time for double clicks and these kind of things. So it's important that you have a realistic value there. I'm sometimes a bit lazy if I just try something new in a new project and I just put the time about 16 milliseconds, so that's like 60 FPS, so it's good enough.
60 FPS, yes.
Yeah, so no need to necessarily actually to count the time. And yeah, the frame function gives you a UI reference, and if you remember the Hello World example that I showed earlier, everything started from the UI reference. So this is the sort of entry point where we can actually start doing interesting things. So far, it's just been set up for the main thing. Okay, so the main thing is to actually construct a user interface. And I don't have an actual example here, but basically you would have some kind of function that takes the UI reference. It would probably also take some kind of data from your game. For example, you could have, let's say, some sprite positions or something, yeah. And the function would then build the user interface by using that data. And the Hello World example, for example, was function like this, because it only needed the UI parameter and built the Hello World window. So after the UI has been constructed, you also need to render it, and we initialized some kind of renderer on startup. So with these built-in renderers, it's very simple. It's just one function call. You give the UI and the target, which depends on the renderer what the type is actually, but yeah, it takes care of that. And that's it. So, yeah, as a summary, so you need to do some stuff on startup to initialize things, and then you need to do some stuff on each single frame. But you can still separate the actual user interface into one function if you want to. And it's not tied to the other things.
I have some questions.
Yeah.
For the Windows content creations, is it necessary that we use GLUT at the moment, or is there any support for like GL, FW, or SLD, for example?
Let me just go back. So the context creation and the window creation.
Yes, and also renderer actually.
Yeah, well, the thing is, these are actually separate things. The context creation, you could use SDL2. I'm using that in my Game Boy emulator, which uses IMGUI. You could use GLUT in here, like in the example, or, well, basically anything. It doesn't really matter.
Okay.
IMGUI really cares more about the renderer, which is, of course, tied to the context creation in some way. So there's currently two renderers. There's one for Bloom and one for GFX. In theory, there could be one for raw GL, so GUI-RS. And I've thought about, this is a bit dirty, but I've thought about Windows GDI or something. Because if you get the draw list and you can render it, it doesn't. You could have everything on the CPU, but I don't want to write the software renderer for those kind of things. So yeah.
Okay.
Yeah.
How does this compare to a control or something like that?
It's very similar. I haven't really looked at Conrad that much, but as far as I understand, it's based on similar ideas.
Just to look at it briefly, but I haven't used
Yeah, I actually considered using Conrad at the time when I needed a user interface for my emulator, so before I even started this. And at the time it was a bit complicated and it pulled a lot of dependencies. This one has, I think it depends on bit flags and this kind of small amount of low-level stuff. And of course Dear IMGUI itself, but it doesn't pull the Piston ecosystem or anything like that. So yeah, trade-offs. I think Conrad is very interesting, and I might even switch to that at some point myself, because I would prefer to have things in pure Rust if possible.
Problem with when I tried it, it was using the for code rendering C++ dependency, and it was pain to work with in Windows. So now there's like the Rust type, which is they're using that.
Oh yeah.
So
Yeah.
try it again. Haven't had need for GUIs yet. We have game project.
All right. Okay. So
Yeah. Yeah.
So I already said something about the different things included in the library, but just a quick overview. So the most low-level crate in GUI is IMGUI-RS, which is basically just a collection of low-level unsafe bindings, all the possible functions that are available. And it actually grabs this C IMGUI library, which provides C-compatible interface to the system, so not directly the IMGUI, the C++ library. So there's like a one level already beneath there. And all functionality should be available. If it's not, it's a bug. So C IMGUI has been sometimes a bit lazy to implement new features, but they are much better now nowadays. So yeah. And here's just an example of a button function in IMGUI-RS. So IG button, you give a label as a C compatible string, not very nice in Rust, but yeah, it's there. And then you give a size as an IMVec2, which is basically just a pair of floats. And then you get the boolean back, which tells you if this button was clicked. Yeah. Then there's the main crate, IMGUI crate, which is basically high-level safe bindings. It doesn't support all the features because some things are complicated and I'm sometimes a bit lazy. But in theory, it should give you access to most of the things in IMGUI while still remaining safe, at least 95%. So here's an example of the button function in the IMGUI crate. So note that it takes a self parameter. So we are inside the UI implementation. So you can't call this anywhere. You need to have the UI reference to call this function. Okay, and in practice, if you want to use this, you also need some support code, which is what I showed earlier. So some input event, context creation stuff, and rendering as well. But yeah, this is the main crate. Then we have the Lim renderer. I just updated, made a release of IMGUI where we now use the latest version of Lim. And OpenGL is supported all the way to, this is actually incorrect, it should be OpenGL 2.0. So I've got integrated graphics on one of my laptops and I really want to run my game emulator there as well for testing. So I've tried to keep the OpenGL version requirement as low as possible. And OpenGL-ES is also supported even though I don't have that much Android or iOS experience.
OpenGL-ES.
Yeah, well, it's embedded systems, I think, and yeah, it's basically on mobile devices. You don't have normal OpenGL, you have OpenGL-ES. Yeah. You can also use this on desktop. That's how I've tested this. You just, I can't remember how you do it, but on NVIDIA cards, you can ask for an OpenGL-ES context, and it will give you that for testing. Okay, and then there's also the GFX renderer that uses the latest version of GFX. GFX is currently doing a very big rewrite of the library, so this is already a bit old, and it will be broken for some time if you want to use the latest features in GFX. So the plan is to, at some point, update to the latest GFX once it's ready, and then also support other backends than just OpenGL. So at the moment, you can't use IMGUI GFX renderer with DirectX, for example, while the GFX in theory would support that, or Metal on Mac OS.
Any plan for Vulkan?
Yeah, that also doesn't work at the moment, but that's very interesting. I think the ecosystems, and game communities are really going forward with the Vulkan, so yeah. I don't know any Vulkan, so pull requests are welcome at some point. Yeah. All right. So just to summarize my recommendations, so use the IMGUI crate, that's the main thing if you want to build user interfaces. Choose the renderer that fits your project. You are probably already using either Lim or GFX, or you need to write your own renderer if you are using something else. And IMGUI-RS is there if you need to use something that's not available in the main crate yet. And this is okay. You just have to be careful because it's unsafe. It's dangerous. But if you know what you're doing, you have access to all the functionality. All right. So after talking about the contents of the library and the basic idea, I want to now talk about API friction. So let's move back in time by around 2 years. So 2 years ago, I think I made a Reddit post first of this library because I wanted to share a very, very bare bones basic version of this after I had used it in my Game Boy emulator for a while. And then the Rostlang Twitter account tweeted my library. This was exciting, there was some publicity, even though the code wasn't the best at the time. And even the developer of Dear IMGUI noticed this. And this is what he then tweeted. That Rust binding looks super strange to me. Not quite the response I was expecting, but yeah. So my initial reaction was this, sad face. But when I thought about it, it's actually true. And this is caused by C++ and Rust being quite different languages. There's different kind of conventions, expectations. So it's very difficult to sort of satisfy both parties. So somebody who has used Dear IMGUI in C++ projects would probably find IMGUI-RS very weird, and probably the other way around. And API friction is real. And I'm specifically talking about friction between some library in C or C++, and then the bindings library in Rust on top of that. Because if you are just building a random Rust library, you have all the design. You can make all the design choices yourself. So it's then more about, is this library good or bad? But when you're building bindings to something, you are limited by some of the design choices of the original library. And this is what I call API friction. And yeah, it exists. It's also okay. It's not the end of the world, but yeah, it's important to know that it's there. So one of the things is strings. This was in 2015 a very big topic. So let's say we have in a source code file, we have the string hello. Yes, I've chosen the for a reason. So what does that mean, that literal string? If we are in Rust, it means that this is an expression that produces a static string slice. It's UTF-8, Rust guarantees this. I don't think there's any way to like circumvent this. So yeah, we can trust that it's UTF-8. It's a slice, so basically it's not just a pointer to some data. It also knows the length. So we know the length in bytes. We know it's UTF-8. And this kind of string can also have interior nulls, so 0 bytes. Rust doesn't care. You can just have anything that's valid UTF-8. Now, IMGUI also likes UTF-8, so if we want to pass anything to the raw Dear IMGUI library, it has to be in UTF-8, but it also has to be null terminated. So there has to be a 0 byte in the end. This is the old C style. And because of this, you can't have interior nulls, because if you had a null in the middle, it would be considered the end. There's no way to distinguish between a null in the middle and null in the end. And if we really think about it, C actually doesn't specify any UTF-8 encoding. So, like the source code file input encoding there's nothing in the standard that says that okay, it's going to be UTF-8 if you write this kind of thing. Okay, and just looking at some encoding stuff, in UTF-8 the Finnish is actually 2 bytes, and with Latin 1 it's just 1 byte. So we could have these kind of combinations from sort of the same text, We can have the Rust version, which has the 2 bytes in the end from UTF-8. We can have the IMGUI version that has those and the null terminator. And we can have the C, old school C GUI version, who still uses Latin 1, where it's not UTF-8, but it's just 1 byte. Okay, so some variations there. Now, if we want to pass a string to dear IMGUI, we can just forget about the C encoding things and just assume everything is UTF-8. So the difference is just 1 byte. That 0 byte in the end. But because we are passing stuff from Rust to IMGUI, we have to add something. We need null termination to make things work. And because we are talking at the moment about string slices, you can't change the length of the slice. You can't append directly to the slice. We need both mutability and probably some kind of allocation. And we need to copy the string and do a lot of work just to add this one null terminator in the end. And also there's the question of interior nulls, what happens. I won't talk about this anymore, but basically in IMGUI-RS, my stance is that if there's interior nulls, it's sort of your bug. It's not going to crash the program. If it does, then that's my bug. But it will truncate your string. It will be the end terminator. So I don't check for those, but they should not cause any harm. But don't use them. Okay. And all this implies actually something very interesting. Static strings are not static. So if we wanted to render text, this hello, we really want this syntax. We want to say UI, text, hello, that's all. That's all. That's very simple. That's the best API we could have. But this literal string here, it's going to end up in a form that doesn't have the null terminator. So the question is, who adds it? Where does it come from? And this is one of the parts where we see some API friction. So the text function could do these allocations and copying and all this to take care of this, but then you start sort of having some potential performance problems, and a big user interface is going to have a lot of these strings. So this led to GitHub issue number 7. If you want all these details, you can go there and read this stuff. But I thought really hard, what kind of options are there, what syntax options are there that could be used? And the first thing is that there could be a macro, IS DEAR. This is the current solution, like you might remember from the Hello World example. You could always require that all strings are wrapped in this kind of IMString struct, and then it would do copying and stuff like that, but it doesn't really, it's not very nice. And then there's the C string type, which is in the standard library, which guarantees that there's null termination. But it doesn't guarantee that there's UTF-8. And every time you create one, you need to check for interior nulls. So it doesn't add anything, it's just worse. Okay? Number 4 is the best choice. If we could have this, we would have this. And number 5 is where the programmer has to insert the null. So if you forget this, either some bad stuff will happen, or we need to always check and maybe panic, like do a nice Rust panic, But yeah, in any case, imagine having to remember this every single time you do some strings. And the last two are just byte string versions. They are just worse. They are ASCII only and have the same problems. Okay, so macros. I don't like macros myself, but in this case, I made an exception. So if we have this UI text str hello, it's going to expand to something like this. So we use the concat macro to put the null terminator there. And the concat macro returns a static string. So what this means is that the hello and the null terminator, that's going to be the literal string. There's no runtime overhead or anything. And then we basically just, since it's a static string, we know it's UTF-8, so we can assume that. And we just added the null terminator, so we can also assume it's there. So then we can just call this unsafe function, which basically ends up just casting this static string pointer to an IMS DEAR. No overhead at all. It's just It's already there in the right form. Okay, no allocation. The null terminator is already in the static string, and we can make these assumptions because we know in that case what's going on. Okay. In practice, you also want some kind of dynamic behavior. Maybe you want to say hello to somebody, so you want a name parameter. This one has some similar ideas, but is still a bit different. So once again, we concatenate the null terminator, but this time we call the format macro. So the hello, those braces and the null terminator, that's going to be the format string. And then we just put the name there. The format macro does the normal thing and puts all the parameters, formats them according to the format string. And as a result, we get a string with a big S, so that's basically a string buffer or, yeah. And then we do basically the same thing. We convert those to bytes, and once again, we can assume that it's UTF-8, and there's the null terminator because we just added it there. Okay, only one allocation should be required here. It's the format macro, which is going to allocate the string for the result. The format string has the null terminator. IM string takes ownership of the bytes, so you could also use this pattern for other things than these kind of temporary strings. And once again, we can assume the UTF-8 and null termination. Okay, so to summarize the macro, if you give the macro just one string, it's going to be static. It's from a performance point of view, it's going to be the same as just any other string. If you add any parameters, then it's a dynamic string, and it's used for formatting stuff. And basically, it's just a different version of format or println, depending on how you look at it. For example, println, which, well, it does formatting and printing, but yeah, that looks pretty much the same. All right. Another API friction is global state. And this is something that Rust really tries to make difficult to use and tries to avoid this in many ways. So in Dear IMGUI in C++, if we wanted to separate between some UI elements, so just empty space, we could call the separator function. It doesn't take any parameters, and IMGUI here, that's just a namespace. So basically the function can be called anywhere. No restrictions at all. The compiler won't warn you if you call it in the wrong place. While in IMGUI-RS, you need the UI reference. And even though it takes the UI reference, because this is a bindings library, it still needs to call the original functions. It still uses global state behind the scenes. And this is one of those things that IMGUI-RS can't change because it's deeply designed in Dear IMGUI. Okay, so if we had multiple threads that wanted to do, let's say, separate user interfaces, this is maybe a bit rare use case, but it's possible in theory. If you have run separator in thread 1 and run separator in thread 2, what happens is it really depends on the timings and other things. It's not because Dear IMGUI is not thread safe. In happy case, you will just get one single UI with like interleaved things, which is not something that you want, but yeah, it doesn't necessarily crash. In the worst case, there's some simultaneous mutation of state in the background, and then it just crashes or does the wrong thing, or yeah, it's bad. So you can't do this. It's not thread safe. Another thing is that since you can call this at any point, what if you just make a C++ program that has nothing else? You just call separator. What happens? There's actually multiple cases. So the first thing is that there's no initialization at all. Nothing has been done. And then there's what happens if you call this function before you've sort of started a new frame, and also what if you call this function after a frame has ended, so it has been rendered. So there's like this, if you think about time, there's like this red areas when the library is not in the correct state. So what happens is a crash. It basically, I don't know if this happens all the time, but at least the cases I've tried, it's a segmentation fault, it crashes. Yeah, but in IMGUI, because you need the UI reference, it enforces some kind of rules about where you can call these functions. Okay, so just a summary. Both libraries, not thread safe, don't use threads with these. In Dear IMGUI, the context has to be in the right state. You need to make sure that you call the functions at the right time. In IMGUI-RS, you need the UI reference, and that enforces some rules. This is a very normal thing in Rust libraries. All right, another API friction, error handling. IMGUI has quite a lot of these kind of function pairs. For example, start something, end something, push and then pop. And what happens if you push once and pop twice? So this is C++ code. It doesn't do any kind of unsafe memory access. You don't get the segmentation fault, but the library uses a lot of C++ assertions. So basically, it just aborts the process, and it crashes, but you don't get the you don't get any kind of controlled thing. For example, a C++ exception. So if you do this, it just shuts down. Now, in IMGUI-RS, you also have the push and pop functions, and they are not any better. It's the same. If you call pop twice after just calling push once, it will abort the process. Because the design is that the C++ assertions are in the Dear IMGUI code. There's no way to avoid those. You don't get the controlled Rust panic, you don't get the backtrace, you can't catch the panic. There's no like this usual Rust error handling things. It just aborts the process. One of the important things to note here is that even though this is not a nice thing, it's not unsafe. These functions are safe. They might do bad things, but they are safe. So, because the C++ assertion is there, there's no way to look, did something go bad and maybe return an option or result or some other nice Rust type. So one of the options is to combine the push and pop into one function. So we know that we call push and pop. And this is the current recommended solution. So there's this with item with, and you give it the closure, which is the code that has to be executed between the push and pop. So in this block, the width is set to this value, and after this block, it's reverted. And this is safe. It doesn't crash, because it always pushes once and pops once. Okay, just a quick list of error handling approaches. First one is make it the programmer's fault. Then abort the process, which is safe but bad. Rust panic, safe. It's all right in some exceptional cases. And even better in Rust code is use return values. So result types or something like that. Okay, but Dear IMGUI uses the first two, and IMGUI-RS uses, well, not the first one, but everything else, depending on what kind of error we are talking about. Okay, the last API friction thing I'm going to talk about is parameters. This is also something very fundamental if you look at some C++ Dear IMGUI code and IMGUI-RS Rust code. Dear IMGUI uses default parameters in C++. So you can just leave out some parameters, and they will use the default values. They also use quite a lot of function overloading, so you've got the same function name, but slightly different parameters. And Rust doesn't support overloading or default parameters, so this is a mismatch. And IMGUI-RS instead uses builders. So when you call, for example, menu item, you get a builder object that has these functions that you can call to set one parameter that's optional. And you can just decide if you want to set that things or not. And finally, when you call build, that's the point when the actual thing is built. And this is quite a different way of doing things. So yeah, there's just a direct comparison. So we are creating a float slider So we've got some data, some float value, and we want to slider. In C++, you just pass some parameters. 0 is min and 100 is max. Because there's no named parameters, you need to also know what those mean. But in IMGUI-RS, you do need this extra build thing, which might seem a bit pointless if you don't like this way of doing things. But when you add some default parameters, in C++ you just add them in the end, and it's okay. In Rust, you need to call these builder functions to set the optional parameters. Okay. So let me try to wrap this up. I still have some things here. So some lessons I've learned. This is very important. I didn't mention this before in this presentation, but eat your own dog food, which means if you are writing a library, make sure you also use it. So this is a screenshot from my Game Boy emulator, where you can see that there's a small overlay there. Well, this is actually a bit silly to show this because I don't use most of the IMGUI-RS features, and this is actually a problem. I only use it for the overlay and some very small things, and that's all. What I should do really is use more features. You can't design a good API without knowing how it's going to be used. Another thing I haven't mentioned before, but documentation is important. So one of the biggest weak points in IMGUI-RS at the moment is that there's very little documentation. This is a typical engineer problem. You just want to write some code and not documentation. And the upstream Dear IMGUI documentation doesn't always help because of the difference in API styles. Even if you could find some example code from C++ code, it doesn't necessarily give you that much hints. And I think this might be, but this is just my hunch, that this is maybe the biggest obstacle to people using my library. And I admit it. I should do better, but it's difficult. Then writing a safe wrapper or bindings library, it's very hard. If you call any C functions, they are always unsafe. You need to think about different kind of cases, try to break your own library. It's full of landmines. And there's a big gap between something that works by accident, works today, or doesn't crash and does sort of the right thing, and something that is guaranteed to work. So it's sometimes very difficult to know if a solution is actually a sound solution that will continue to work. And I'm completely sure that IMGUI-RS still has safety holes. In fact, I know some. One is the thread safety. You can initialize the library twice and then break it. That's possible. And yeah, but there's some probably a bit more evil safety holes there as well that I need to find. And I wasn't personally at the Rust Fest Zurich this year, but the Glium developer had this very nice presentation about mistakes to avoid when writing a wrapper around the C library. So if you have any intention of writing any wrappers, watch that. I learned some stuff from that presentation. Okay, and API friction that I've been talking about, not all is fixable because when you're binding to another library, you need to just work around some design things if they cause complications. You can't just fix everything. I could, of course, just fork Dear IMGUI and fix everything, but my way, but that would not be good for maintenance reasons and other things. But yeah, even if there is some API friction, if you have the right trade-offs and the annoying things are not too annoying, you can still have some library that's useful to some people. So it's all about the right trade-offs. It's difficult, but possible. And some things that are simple in C or C++ world are not necessarily simple, especially in Rust, because C and C++ give the programmer a lot of foot guns and other things. And normal functions in Rust libraries are usually expected to be safe. So if it's not marked unsafe, it should not cause a segmentation fault, even if the underlying library makes it difficult to avoid. All right, just some quick future plans. I want to use the latest IMGUI, Dear IMGUI. They had a release like 2 months ago. Those features are not yet supported. The GFX renderer needs some work. It's a bit rough on the edges, so also the new GFX version, they're doing the rewrite. Once they are done with that, I want to really fix the renderer. And also high DPI support is broken. It sometimes works on some configurations, but not guaranteed to work. All right, and then some new features I'm planning. IMString, there's this small like crate that lets you allocate from the stack in some cases. So even when doing these dynamic strings, if you remember the IS DEAR macro, you could have no allocations in most cases. This is a sort of a micro optimization, so it should be quite simple. Also, custom draw list manipulation. You could create your own widgets just by calling some functions like, I don't even know what they are in the upstream library, but yeah, that would make it possible to extend this library with new widgets. Also, custom images. At the moment, you can't draw custom textures. For example, my Game Boy emulator, it draws the Game Boy output and the user interface separately, instead of like the user interface containing a nice Game Boy window or something. This is complicated, but definitely on my to-do list. And also, I'd like to provide some help code in the crates for SDI2 and Bluetooth integration. So at the moment, people copy-paste my example code, which is okay, but I kind of feel like I should provide some crate they could depend on. All right, that's all. Here's a GitHub link, and I will post at least the slides later if you want to take a look. And let's see if that video recording has worked. Do you have any questions at this point?
How many users do you have? Are you aware of?
Depends on what you mean by user. Stars in GitHub, I can't remember, some hundreds, I think. No, 200, something, not very much.
250. Right.
Yeah, it's all right. But actual, let's say, big projects that use this library, not very many. So yeah, we have SHA, yeah, the game, and I can't remember any other projects. There's also at least one game engine. I think it's Kappa, something. Yeah, I think they also integrate this library, so you could build a game with that engine and have all this functionality easily available. Yeah, I think that's
How
all.
much time it has been since your first comments on this this library? 2 years.
Yeah, I think it's around 2 years. Oh yeah, there's the license. What's the easiest way to find it out? I don't think I have the Git project on it.
Well, it's good, yeah, but then you need to click next.
Yeah. Let's just see. I can't remember if I have it on this machine. Yeah. Yeah. 2015, around 2 years ago. Although I had a private repository with it before this, but yeah, maybe you could add 6 months to that, so maybe beginning of 2015, something like that.
How much do you spend time on this?
Sorry?
How much do you spend time on this on a regular basis?
It varies quite a lot. Sometimes I go into this crunch mode and do some big changes and fix things, but quite little. So this is one of the eat your own dog food things. So I'm very busy with my emulator things. That's my main focus.
Okay.
But I don't need a lot of user interface work. So this library is unfortunately the secondary thing. But yeah, maybe let's say 10 hours every 2 weeks, something like that.
Personally, I have to say that apping friction is really there.